All right, so what happens if you put money in an account and it compounds every day? You can imagine how much money you're going to have after so many days. What if it compounds every hour? You'd imagine you'd have even more money after the same amount of time. Every minute compounding would result in even more money. What we're going to talk about in this video, though, is interest that is always compounding. It never stops. It compounds more than every second, more than every nanosecond. And the cool thing about this is you would think that if it's always compounding without ever stopping, you would have an infinite amount of money in no time at all. And that's actually not the case. In fact, there's a number in mathematics called E. You should be able to find it on your calculator. Let me see if I can show you where mine is on my calculator. So let's see here. Let me refocus. So my E button is right here on the same button as pi, okay? You'll either have a button like that, or you could have, let's see, e to a power, like this one here. So if you want to know what e is, you could type e to the first power. But really, e is what we call an irrational number, and it's much like the number pi. When you write it as a decimal, it goes on forever and never repeats. And the reason it's important is precisely for this concept of continuously compounding interest. Okay? You don't have an infinite amount of money immediately. It's actually going to, the curve is going to grow like the number e. So this number e it's just a number. It's a button on your calculator that you can use. It's about 2.71828. Okay? But it keeps going forever and doesn't repeat, so we can't actually write it down, and that's why we give it the symbol E, much like we have the symbol for pi, okay? Now, if you want to calculate continuously compounding interest, this number E is involved. And the way to do it is the amount in an account that starts with a principal of P dollars will be P times this number E raised to the power of your annual interest rate, R, times the number of years, T, okay? So let me label all that here. The amount in your account will be the principal, the initial amount invested, the principal, times E, that number on your calculator, to the power of R. R here is literally your APR, your annual percentage rate, your interest per year. Now you'd put it as a decimal, okay? So you'd have to convert it to a decimal. And T is the number of years. It's the time in years, okay? These two guys have to be compatible. So this is an annual interest rate. This is an annual amount of time. All right, so that's all there is to it. So typically students might remember this as A PERT. Without all the dots and parentheses, this is what it looks like. A equals P times E to the RT, okay? So let's practice with this. Very simple once you know the formula. I'm not gonna get into exactly where this E arises in this video. That's more of a calculus topic. It's really interesting. Maybe I'll make a video on that one day. But let's say, how much after 10 years with APR with an annual percentage rate of 2.3% compounding continuously. Compounding continuously. Not yearly, not monthly, not quarterly, always, okay? So how much is in an account? If $5,000, let's make that our principal, if $5,000 is invested. Guess we need to know that, right? Okay, so it's very simple. So we need to know our principal, right? The formula is A equals PERT. So A is what we're looking for. The principal is $5,000 times E to the power of R, which is 0.023, 2.3% as a decimal, times the number of years, 10. Okay? And then you just type that into your calculator. 5,000, I'm typing it all at once, times E to the power of 0.023 times 10. Let me show you what that looks like on this calculator. Let's see here. Try to get it focused on there. Maybe I'm too close. There we go. And when I did the E to the power, I just used this button right here, and then I typed my exponent up there. Okay? So it looks like that is about $6,293. And so you can see that compounding continuously does not yield an infinite number of dollars. In fact, over a full 10 years of never pausing in how it compounds, you still only earn about $1,300 in interest from where you started. So the value of E is really fascinating, and you can see its usefulness here.